This is June 2016, paper 1, question number 5. The resistance of an LDR is affected by the amount of light that shines on it. A student investigates this relationship using the circuit shown. The 2 marks, they want us to add the voltmeter to the circuit diagram so it measures the voltage across the LDR. So first of all, we've got to identify which one of these 4 is the LDR. This is an ammeter. This we should know is a variable resistor. Here is a battery, leaving this one to be our LDR. And then all we have to do is terrible drawing, but the voltmeter has to be connected in parallel with the component. Explain how the student can work out the resistance of the LDR using this circuit. Well, you would use the ammeter to measure the current. And then you would use V equals IR, where R equals V over I. And then you do the voltage divided by that current, and that's how you'd measure the resistance. Very simple and straightforward. So we take this now, and the student shines the light on the LDR through a circular hole in a piece of black card, as shown in the diagram. The student repeats the experiment using holes of different diameter. The distance from the card to the LDR is always. The student varies the current in the circuit by adjusting the variable resistor. So what they're asking us to do is identify the independent variable. Well, here the independent variable is the one that's changing. So I know that the one that is going to change is the diameter of the hole, because we're using different diameters. What is controlled in this experiment? Well, that is going to be, it's always 5 centimeters, so the distance from the card to the LDR. That's going to be one of our controls. The photograph shows how the student places a metal ruler to measure the diameter of one of the holes. Suggest how the student can improve this technique while still using the same ruler. Okay, so we want to measure the diameter, which is that distance. How can we do that? Well, the obvious thing would be to move the ruler to cover half the hole. We want to use the same ruler, we just want to make it a bit more accurate. So from here, we'd have to read to here, and we could get that wrong. So if we just move the ruler down a little bit, where it cuts the hole, we could make a much more accurate reading using that same ruler. The table shows the student's results. Got a list of results here to see if these all make sense. Yeah, as the diameter of the hole goes up, the resistance should go down. We know that about an LDR. You would plot them. I'm not going to plot them here, but you should come out with some plot that looks a bit like this. You should have resistance here, and you should have diameter here. That is always the same for every single graph. Well, no, actually, most graphs are going to have the independent on the x-axis and the dependent on the y-axis. So that's the way we set up these tables. This column is always for the x, and this column is always for the y. And then we should obviously put things like this is the units of here as well, millimeters, and then you're going to plot them appropriately. We don't want anything that's half the size of the graph. This one you could have done 0, 200, 400, blah, 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 blah. And then you would have got 1200 at the top, which is, I mean, if you went up, that's the biggest scale you should be using. And then that would go for 30. Describe how the relationship between the resistance of the LDR and the diameter of the hole. Describe that relationship. Right. You've got, as one goes up, the other goes down. So it's an inverse relationship. As one goes up, the other goes down. What we're looking to see when you're talking about the relationship between them, look at the pattern. Look at what happens between the 2 values. So don't just say it's curved. What is actually happening? So it's an idea of an inverse relationship here, idea that it's non-linear. That would be great. So why doesn't, if this, as one goes up, the other goes down, why isn't it just a straight line then? So there is something weird that's happening. So it's an inverse or non-linear relationship. Okay, and that's question number 5.